Planet orbiting backwards. A groundbreaking discovery. Buckle up. Astronomers may have just found a planet that spins our understanding of the cosmos on its head. Imagine a world orbiting not with, but against the natural flow of its stars. Sounds impossible? That's exactly what scientists have confirmed in the mysterious new Octantis star system. But here's where it gets controversial. This one discovery threatens to upend decades of accepted models about how planets are born and survive in challenging double-star environments. Let's dive into the details. The new Octantis system, about 2.9 billion years old, is made up of two stars. New Octa, a hefty subgiant about 1.6 times heavier than our Sun, and its companion, New Oct B, only half as massive as the Sun. They're locked in a slow-motion cosmic dance, circling each other every 1,050 days. Although a strange planetary presence was first hinted at back in 2004, only recently, thanks to ultra-precise readings from the European Southern Observatory's powerful HARP spectrograph, did researchers confirm the shocking truth. There's a planet here, and it's orbiting backwards. Why is this so wild? Here's the part most people miss. Nearly all known planets orbit in the same direction as their host star's rotation, neatly following the swirling disk of gas and dust left over from star formation. Yet, in New Octantis, the planet's orbit bucks this trend, instead moving almost perfectly in the opposite direction to the twin stars' dance. This is called a retrograde orbit, a phenomenon so rare, especially in double-star, binary systems, that many astronomers thought it might be impossible. Stable retrograde planets shouldn't last, or even form, when bombarded by the tug-of-war gravity of two stars. So how do we know for sure? The team, led by Professor Man Hoi Lee at the University of Hong Kong, poured over 18 years' worth of stellar motion data. By tracking subtle shifts in the star's position relative to Earth, a method known as radial velocity analysis, they pinpointed the planet's backwards path, almost perfectly lined up with the plane of the star's own orbit. For the skeptics, even more meticulous readings from HARPs clinch the case. The implications are huge. What if retrograde planets are less of an extreme rarity than we thought? Could other oddball worlds be hiding in evolved systems with dying or dead stars like white dwarfs? And this is where the history of New Octantis turns even more fascinating. New Oct B, now a faint remnant called a white dwarf, started life far heavier, around 2.4 times the mass of the Sun. Over a massive transformation spanning billions of years, it lost over 3/4 of its mass. This epic process may have created a swirling disk of gas and debris, prime ingredients for second-generation planets to emerge in the aftermath. Maybe the weird planet in New Octantis was born from this stellar shrapnel. Or, perhaps even more bizarre, it was captured, yanked from a regular orbit, and flung into its present-day retrograde route. Either way, the star's tumultuous history shaped this one-of-a-kind arrangement, making normal planetary birth here essentially impossible. Dr. Trifon Trifonov, one of the study's co-authors, offers a bold hypothesis. What if this opens a Pandora's box of scenarios for planet formation? Could there be entire families of planets in the cosmos born not in the shadow of starbirth, but forged from celestial death and chaos? But controversy lingers. Some experts might argue this finding fits more into the realm of cosmic anomaly than a rule changer. Are we jumping the gun in redefining how planets can form and survive? Or does this provoke us to consider that our solar system is the true oddity? So what do you think? Does this discovery shatter our current models, or is it merely a cosmic fluke? Could there be galaxies teeming with rogue planets on wild backwards paths? Let us know. Should this lead to a rewrite of planetary formation theories, or is it just another intriguing exception? Share your thoughts below.